In this video, we'll be going over another circle question where we'll be looking at the different areas of the circle and using that to calculate the annulus. And we have our unknown value n here. This is a GCSE question that's non-calculator and it's aimed for the higher tier papers. So, the region R, shown shaded in the diagram, is the region between two circles with the same center. The outer circle has radius 2n plus 6. The inner circle has radius n minus 1. All measurements are in centimeters. The area of R is greater than the area of a circle of radius n plus 3 centimeters. n plus 13 centimeters. N is an integer. Find the least possible value of n. You must show all of your working. So we've been asked to show all of the working, so immediately we know that this question is a high marking question. But that also means we can easily pick up the marks if we show every step that we do, and if we label our steps as well. So the first thing that we want to do is we want to form our inequality. So we know our areas of the circle, which is pi r squared. And we can immediately identify that with the 2n plus 6 squared and the n minus 1 squared, we're going to have to do some expanding brackets, some simplifying, and we have to take into account our inequalities along with taking the rules for the area of the circle and all that kind of stuff. So this question is a synoptic question that they've made that covers a wide range of topics that they can easily ask you in any exam. So these are the kind of questions where they will really test your understanding of maths and can show whether you can bring together two different topics and two different ways of solving a question to get your answer. So, to first form our inequality, we're going to have the area of our larger circle, 2n plus 6. That's our radius, and we're going to take that as pi times 2n plus 6 squared, the whole squared. Now we're going to take our smaller circle. And the area of that is pi times n minus 1 the whole squared. And now to find the area of our annulus, our shaded region R, we're going to subtract the area of our larger circle from the area of our smaller circle. Pi times 2n plus 6 the whole squared minus pi times n minus 1 the whole squared. And now we can straight away put in our inequality. So pi times 2n plus 6 the whole squared minus pi times n minus 1 the whole squared is greater than, and as it says in the question, it's greater than the area of a circle with radius n plus 13. So we have pi times n plus 13 the whole squared. Now on the left hand side, we can factorize out pi, and we can divide both sides by pi. So this can give us pi times 2n plus 6 the whole squared minus n minus 1 the whole squared, and this is greater than pi times n plus 13 the whole squared. So divide both sides by pi, and we're now left with 2n plus 6 the whole squared minus n minus 1 the whole squared is greater than n plus 13 the whole squared. Now what we have to do is we have to expand our brackets. And so we're going to start off with our 2n plus 6 the whole squared. So for these kinds of brackets in the form of a plus b the whole squared, we can expand it as a squared plus 2ab plus b squared. And so this is what may be also called the binomial coefficient. And now for a minus b, the whole squared, in this form, this is a squared minus 2ab plus b squared. So that's only if the brackets are given in this form can we expand it. So let's do our 2n plus 6 the whole squared first. This follows the a plus b the whole squared format. So we have a squared, so our 2n squared, 2n the whole squared, plus 2 times 2n plus 6 times 6 plus, and then we end with 6 squared. And so this is equal to 4n squared plus 24n plus 36. Next we'll be doing n minus 1 the whole squared. So in this we have a squared minus 2ab plus b squared. So we have n squared minus 2 times n times 1 plus 1 squared. And this is equal to n squared minus 2n plus 1. In this scenario, we can take 1 in our brackets because we know that it's a minus 2 times a times b. But if it's a different value, remember to take minus b instead of just b. Only in this can we take just b. And now we will end with n plus 13 the whole squared. And we expand it in a similar way. So this will be a squared plus 2ab plus b squared. And so we have n squared plus 2 times n times 13 plus 13 squared. And this is equal to n squared plus 26n plus 169. Now we can substitute this back into our equation. So what we're going to write here is we're going to have our 4n squared plus 24n plus 36 minus, and then in brackets we're going to have n squared minus 2n plus 1. And this is greater than n squared plus 26n plus 169. Now we're taking the minus outside of our n minus 1 the whole squared because that's how it's given in our question. And then we're also going to have to multiply everything inside our brackets by minus 1. So if we keep it outside, it will help us to remember and we don't go wrong when we're multiplying by minus 1 because of the change of signs. So what we go to now is we have 4n squared plus 24n plus 36. And now we're going to multiply everything in our brackets by minus 1. So we're left with minus n squared plus 2n plus minus 1. And this is greater than n squared plus 26n plus 169. Now we can simplify everything on our left-hand side. So 4n squared minus n squared is 3n squared. (24n) plus 2n gives us 26n. And 36 minus 1 gives us 30 plus 35. And this is greater than n squared plus 26n plus 169. Now what we can do is we can move everything on our right-hand side onto our left-hand side. So we put all our n values together and our integers as well. So when we join it together, we get to something similar to a quadratic format where we have an equation equal to 0. And then we can solve it from there. So if we move everything to the left, we have 3n squared plus 26n plus 35 minus n squared minus 26n minus 169. And this is greater than 0. Now when we simplify, 3n squared minus n squared gives us 2n squared. The 26n's cancel out, so that's just no value for n. And then we have 35 minus 169. Now if you do it, you will get minus 134. And this is greater than 0. Now we can divide both sides by 2, so we get n squared minus 67 is greater than 0. And now what we can do is we can move our minus 67 to the right hand side, so we're left with n squared is greater than 67. Now we know that n is an integer because it says in the question here n is an integer. And we're meant to find the least possible value of n. So we need to find an integer value of n that, when squared, is greater than 67. So we know that 8 squared is 64, but this 64 is less than 67. The next integer up from 8 is 9, and 9 squared is equal to 81. This is the first integer value that has its square greater than 67, so our value of n is 9. And so this is the kind of working out you have to do to get all 5 marks. But usually these questions should take up most of your time because you have to include all of your working out. And so make sure you get these marks as well. Even if you don't know if you'll get the right answer, you'll get marks for method marks.
As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.